So in this question, they are saying that you have 69 factorial times 68 factorial. So it's a product of the factorials. You have to figure out the 197th digit from the right end of n. So obviously this whole thing, like 69 factorial itself, will end with a lot of zeros. And so the product of all of such, so there will be lots of zeros here. Okay. So you start counting first, second, third, fourth from the right end. You count. You reach the 197th position, and you have to figure out what is this digit here. So there's a very high chance that it will be 0. Okay. And if it is not 0, then it's very difficult to figure out what it is, because I mean, you can't just calculate it out, right? I mean, 69 factorial, a lot of zeros, and then what is the last non-zero digit is going to be really tough to compute. And then you have to compute that for each of these numbers and then compute. So that will obviously, logically speaking, cannot be a question in a test like this. Okay, so sometimes we can like kind of reverse engineer what the thinking could have been, okay, rather than actually just start solving something. So even if, let's say, I don't have, and this is a theta question, if I don't have time and I have to just mark something, I just mark 0 and move on. Okay, now let us just verify that 197 digit is actually 0. So 69 factorial, if you look at, so for finding out the zeros, the power, this I have to look at the powers of 10. Powers of 10 means powers of 2 and 5. Obviously 2 will be way higher, so we can just ignore that. We'll just focus on the 5s. So 69 factorial for 5 would be 69 by 5, that's 13, and 13 by 5, so you'll get 17. So 5 to the power 17 basically. So now 69 factorial, then 68 factorial, 67, 66, and 65, all of them will have the same number of 5s, because no 5s reduced or removed when we reduce from 69 to 65. The number of 5s would get reduced at 64. Okay, so all of them have the same number of 5s. So you have got 5 of them, so 17 plus 17 plus 17, like that. So essentially we already have got 5 to the power 85. Now for 64, obviously there is 1 5 less, because 65, the number 65 is just 5 times 13, there is 1 5. So we don't need to again do the whole thing. We can just say it will be 5 to the power 16, and again it will come 8 times. So it will be 5 to the power 80. So that already makes up 5 to the power 165. Okay. Now this will continue till 60. 64 to 60 we have already reached. And now from 60 onwards, 59 till 55. Again, 1 less 5 now. So it will be 5 to the power 15 and 5 times, so 75. So if I add this exceeds 200. So 197 digit is clearly 0, because you already have more than 200 zeros at the end. So 197 digit is obviously a 0. So that's your answer.